Hello everyone, welcome to another episode of DPC. Now I know we've been working on the big van, the big drone, the Shrike Ultra, but I wanted to kind of revisit the Stubby Fan here, because for a while now I've been trying to basically figure out a way to machine the planetary gear system that I've created here so that we can engage this fan. Now, this holds the motor for driving this system, and I'll get to the explanation here in a second. So the same 7070 Flip Sky motor that I'm using right now on the Shrike Ultra is also the same engine that drives this. Now typically this will sit inside the engine here at the front. We're going to take this casing off here for you, and we'll pull out the guts, which will make things a little bit easier. So now we have, that's how it sits, and the shaft goes through and engages the gear system. The gear system itself is actually this little doohickey. Now, I'm having this done out of tool steel because we finally got the right ratio for it. And it basically gives me a 4-to-1. So you can see how much faster that one wants to turn in the center. The sun gear was always the issue. And with printed materials, the biggest problem with this planetary is that it didn't hold together. It would strip the teeth out. So we do it out of tool steel for the sake of everything being smooth, turning smoothly. That's what we want. We want that center to spin because it engages that little index inside the fan housing. And this entire unit basically slides straight in here and engages the fan. And that's what turns the whole unit. Then the collet, the same type of collet that goes on top of here, that goes on the Shrike Ultra, basically with a 10mm shaft input, gets screwed into the top of this rotator that rotates the planets. Then the motor mount sits here, and as you can see, the shaft will go down and engage the collet and spin the fan. That'll give me a 4-to-1 gear ratio and give us a fan that can basically put out a lot of RPMs. Now, I did originally build this to be a rear drive system, but it's swappable, so it can go front to rear. If you're mounting this in a jet just like this, the motor can be in the front, which is cool because then the ducts that actually pull the wind in can cool the engine off as it goes through, as opposed to having it within the wind tunnel where you want more linear, smooth air flow. You don't want an engine behind there basically getting in the way of that. So that's the idea behind this fan unit. The 22 blade high pass, and it rotates at a 4-to-1 gear ratio, and is basically as modular as you can get it. So now you're able to, after I get these printed, of course, they're going to be, sent to me, and it's going to be tool steel that we're going to be using. The fan itself, I may have done in alloy as well, just for the sheer sake of it. Probably a 7075 aluminum instead of PETG, because we're looking at about 20 some odd thousand RPMs roughly, which is plenty for how aggressive this fan is. So we haven't forgotten about our beloved Stubby Fan. We have just been working on it, making sure everything works correctly, working with the company that's going to be doing this out of the tool steel, getting all my measurements correct, and making sure everything is the way we need it, so that when we put this one back together, we have a full unit that can be dropped into an airframe, that can be dropped into a powered glider, that can be used in a drone. Anything you want. That was the idea behind that. Now, the casing that I did design for it is merely for testing. So the idea is that it pops right in there. And I pop the top on. I get everything screwed together through the front here, and then we bolt it down to the scale and we do the pull test. So that's the idea behind that. But this is not the permanent case for this. This is merely just for testing. So what we want to do is build a system that you can just drop just like this into an airframe that you design to accommodate that geometry. And then, like, say an F-35 or something to that effect, and still have those really high RPMs, a lot of thrust, a lot of moving air, and you're not paying thousands of dollars for a huge EDF system. This is as close to the real thing as you're going to get in the scale RC world. So as soon as this is finished, I'm going to be excited to actually test it out and get everything wired up on it, put it on the stand, and we'll see what kind of thrust that she'll make. But I kind of wanted to let everybody know that Stubby Fan is still on the table. I just got really, really, really into the Shrike. You already know that, right? There's a lot going on here. I'm doing some anti-vibration controls here, making sure everything's spinning correctly and getting everything lined up. This is the motor I'm talking about that will be used to push not only the Shrike Ultra, but it'll also be the same engine that drives Stubby Fan. So we're working on both at the same time. I'm doing everything I can. This will take not too long to get in, I think. I think we'll end up getting these gears in a week or two. ESCs are coming for this now, and the other motors. One more battery, and then we'll get this big girl in the air. Good Lord, that's a big fan. I mean, it's a big drone. 340 millimeter fans. You can't beat it, right? But I wanted to give everybody an update, not just on this, but on the fact that, because I know a lot of people missed Stubby Fan. I mean, I have a whole mug dedicated to Stubby Fan. That's the kind of stuff you want right there. And now that I got that 4-to-1 gear ratio set, now I can have it machined. So it took a little while for me to get the right ratio because I was using different gear patterns and trying to figure out which material, which alloy was going to do the best in that gear system. So as far as heat mitigation is concerned, it's going to be basically a sealed gearbox with regular old gear grease in it, or an oil of some kind, probably something with a low viscosity. And then between these arms here, we're going to put some aluminum fins that come up. And the idea is that it cools off the entire casing and the oil inside as it's running. And this entire piece here is going to be machined out of the same aluminum as a fan. So we want to try and keep it as 3D printed and modular as possible. It's just that this drive system requires so much torque that it kind of has to be on an alloy. You're not getting away from it not being an alloy. That's just all there is to it. But it is a beautiful fan. It's survived a lot of testing, that's for sure. And it is using the same motor that's driving these fans. These 340 millimeter high-pass fans. So stick around for the updates, because we will have updates for this one soon. And updates for this one. Because who doesn't want a motor you can just drop into a custom F-35 that's 170 millimeters and puts out more engine power than most of those $5,000 EDFs, right? At a fraction of the cost, because you can print most of the pieces. Some you'll have to make out of metal. That's not something you're going to get out of. But, to be honest, if this is successful, as I think it will be, I'll just start ordering stuff in bulk. Just building these engines out and being like, hey, here's what they cost me. Here's a little bit of a markup for my work. And I'll make these available to you. It's just a wonderful system. It's going to put out a lot of power. It's just I can't wait. I was always excited for this fan. It was one of my first. And then these guys came along. And my brain went wild. So we're getting there. So don't miss any updates, because there's a lot to do, a lot to build, and a lot of flying to do. Fingers crossed on this one, I'll tell you that. I'm probably going to get a lot of vibration at first, but we'll get it worked out. So stick around, because you do not want to miss everything that's coming up.